Hello, how are you? What I want to do is do two examples of the homework on logic that you have to do. So here's the first example. This is actually from Lewis Carroll. I'm going to let T of X mean X is made of tin. I'm going to let S of X mean X is a saucepan. And P of X mean that X is a present from you. And U of X means X is useful. So the universe will be all things I have, basically. Now, the first one becomes for all X, if it's made of tin, my first statement is going to be anything made of tin is a saucepan. I translated it there for you. The second statement is going to be anything that's a present from you is useful. My third statement is going to be, if I have a saucepan, it's not useful. What I want to prove is that if you give me a present, P of X, it's not made of tin. So I convert the statements one by one into the simple solution, just not A or B. And then I put in the negation of the conclusion. You always have to put in the negative of the conclusion. What you're trying to prove is that by putting that negative in, you can reach a contradiction. So since you put it in, it can't be true. And the positive must be true. Now, the negative of the conclusion is not for all X, blah. When we have a not in front of a for all, then that becomes there exists not. Think of that carefully. If not for all things, then surely there exists one that it's not true for. So I put the not in front of the statement. PX implies not TX. I turned the PX, I got rid of the implication by using the not PA or not TA. You notice it's not universal. So I had to have just the name, A. And then I just got rid of the quantifier, and I got PA and TA. Now that means that PA and TA are both true. So they're going to go in as separate items in the list. I don't put PA and TA because I'm saying that both are true, so each one is a separate item in what I'm trying, my premises or my conclusion, my negative of the conclusion. Now here's where we start playing. There are many strategies that could be used. One of the easiest strategies is to always use single clauses if you can. PA is a single clause. TA is a single clause. We could use either one of them at the beginning to see if we could eliminate some things and get down to smaller and smaller clauses. So I'm saying 1 and 5, if I use those together, they give me SA. I substituted A for X in 1. I got TA and SA, not TA and SA. I have TA, so it doesn't matter whether the T is true or false. SA is what determines the thing. Then I did exactly the same thing for 6 and 3. And I might put it all up there. 6 and 3. 6 was what I just got, SA. I clashed it with 3, and that gives me not UA. Then I took what I just clashed, 7, and I clashed it with 2, and that gave me not PA. But if I have not PA, then I can clash it with, pardon me, that's 4, and I get my contradiction. Now this is the way I do it, because I have some intuition looking at it. It's not the way the computer will do it. The computer will possibly try everything, all kinds of things. But we don't want to go out through the deep ends, the dead ends. There's another way to draw this that might be even more easy for you to understand. You can draw it in sort of a diagram. It says 1 and 5 together give me 6. 6 and 3 clash to give me 7. 7 and 2 clash to give me 8. 8 and 4 clash to give me a contradiction. Because I have not PA and PA. I can't possibly have both of those. So that's the first example. Now I got that from Lewis Carroll, a website on Lewis Carroll. Although Lewis Carroll's puzzles, you have to decide what you're going to prove. So that sometimes figuring out what you're going to prove is harder than proving it. My second example I got from another site somewhere, and this one is also relatively easy. I'm going to have 2 predicates, both binary predicates. Pxy means x is a parent of y. Gxy means x is a grandparent of y. And I'm giving you the following facts. Joe is the parent of Mike. Joe is the parent of Sam. Mike is the parent of Albert. Sam is the parent of Luke. And I'm defining grandparent for you. If Pxy and Pyz, then that means G is the grandparent. That means X is the grandparent of Z. I want to prove that Joe is the grandparent of Luke. Now, if this were a computer doing this, the computer might take, well, first of all, let me translate everything for you. The negative of the conclusion is just not GJL. And when I took 5, I took not the first clause or the second clause. And this is an and, remember. And then not and and is the or of the nots. That's the De Morgan law. And that gives me all ors there, and that's what I want. Now, if the computer were doing this, it'd take PJM and clash it with 5. Then it'd take PJS and clash it with 5. PJM clash with 5 would be a dead end. But we see that it's not worth it. We're going to start with PJS. So if we take 5 and 6, then not GJL, I put in here, I wipe out the GXY here, but to do it, I have to make XJ and ZL, because I had GJL. JL means that, I got that wrong again, pardon me, that's a Z. So I got the L there. Now with that, well, that's giving me something, but I'm not there yet. Now I take what I just did and I clash it with 2. PJS. Well, that means I make YS. Now I have not PSL, but 4 says PSL. That gives me the contradiction. this looks almost the same as the other one. This is a strategy. It's one way that people cut down the exponential growth in doing logic puzzles. They say always take a single clause if you can. And also you'll notice I always take the last conclusion I made, 7, and try to find a single clause to clash with it. That again is part of the strategy. So that's how you do logic puzzles. I think they're relatively simple. Oh, they can get complicated. But I want to emphasize that in the computer, you would generate a lot of dead ends. And you can imagine that there'd be 200 statements. And you could get really lots and lots of statements that lead nowhere. That's why you would have strategies like this of always using a single clause instead of the ones that are more complicated. That's it for now. I'll put out these files and I'll post the video. See you later.